we use a subscript of 0 on almost any variable to mean that variable at time t equals 0. So for example, x0 means the position at t equals 0. Of course, another way to write that would be x of 0. I don't use this. One of the reasons we don't like this notation in physics, and I almost never use it, every now and then, but almost never, this gets confusing with x times 0, since a lot of times we use parentheses to indicate multiplication in algebra. So I don't like this notation, and most physicists don't use this notation because of exactly that confusion. Position at t equals 0. V sub 0 means the velocity at t equals 0. And of course, a sub 0 is the acceleration at time t equals 0. In many physics problems, you can move the origin wherever you want, and you can also start your stopwatch whenever you want. So there are a lot of problems where you can set the time 0 at some very convenient point. It simplifies, this notation simplifies a lot of things. A delta t comes up a lot in physics. Delta t, which is normally written as t final minus t initial, if you start your stopwatch when t equals 0, then you have this becomes t minus 0, which is just t. So you can shorten the time interval to just t. That's something that we do a lot. You also can shorten other intervals, or at least write them differently. The displacement is written as x final minus x initial. And if you're using that notation, you can replace the x final with x at any given t minus x0. Okay, it only saves you one subscript, but still, saving one subscript is a lot if you're going to continually write lines of algebra that have that x. So that x, remember, means the x at any time t. And again, the notation x of t, I'm not writing it that way, so well, also to save strokes of the pen, but also because, again, that's confusing, could be confusing with multiplication. This means x as a function of t, not x times t. So this notation, though, this x could be an x at any position t, and if you have both a delta x and a delta t, the idea is that that's at the same t as if you were using, I had that on the other slide, t minus 0, say. This t matches that t, so this x happens at that time t if you're using those two in the same problem. Of course, between problems, you can change where your stopwatch is. So that allows simplification for quite a few problems and makes things a little bit easier. The velocity would obey the same rule. If you wanted delta v, v minus v0, then that becomes v final minus v initial. It could be written this way. Another thing that this notation allows is it allows a quick way to say when a quantity is constant. If the velocity is constant, one of the ways we write that in physics is we say that v equals v0. And what this means is, this means the velocity at any time t is equal to the velocity at t equals 0. If the velocity at any time t is equal to the velocity at the time 0, the velocity must be constant.